The faster an object moves through the air, the greater air resistance it experiences. Air resistance, also called drag, is the force that is in opposition to the relative motion of an object through the air. To learn more about air interacting with objects, we will introduce Professor Alfred Bedard from the University of Colorado Boulder.
My background is I'm a physicist, and I work for NOAA and also something called CERES. I'm an adjunct with the aerospace department and the mechanical engineering department. Okay.
Trains are one of the fastest modes of transportation on Earth. Trains have a really aerodynamic shape in order to reduce the drag due to air interacting with objects. Did you know that the fastest commercial train in the world is the Shanghai Magnetic Levitation, or maglev train, reaching commercial speeds of up to 431 kilometers per hour? Can you explain more about air interacting with objects?
So I guess one of the key things is when you have flow interacting with an object, there's a normal pressure. Here in Boulder, it's 820 millibars is standard pressure typically. And then on top of that, if you have wind around an object, or if you're trying to measure it outside, you'll end up with a dynamic pressure because of the wind interacting with your port or opening on top of what the ambient pressure is. And these dynamic pressures can be exploited for good, or they can cause errors in the case of aircraft altimeters.
The standard, or ambient pressure on an object, is the pressure of the surrounding medium, such as a gas or liquid, which comes in contact with the object. If an object is not moving, the measured pressure is the same in all directions. For example, when the train is stationary, it is acted on from all directions by ambient pressure, called static pressure. But if it is moving, the measured pressure depends on the direction of motion. When the train is moving, air resistance is a pressure acting in opposition to the relative motion of the train and is termed dynamic pressure. How can you apply this principle to reduce air resistance acting on objects?
I'd say take a look at cars, automobiles that are designed for high speeds. Take a look at the Ferrari, for instance. Take a look at some of the racetrack cars that are designed for racetrack driving, and see if you can learn something from there. And people, as I say, I think we can still learn how to reduce drag on aircraft. And one, for instance, a golf ball has these little bumps on it. You can ask, why is that? And it turns out that it reduces drag and makes a golf ball much friendlier than a perfectly smooth golf ball. It modifies the boundary layer around the golf ball, and so you can think of ways that you might deliberately roughen your design and make it even more aerodynamic, which sounds counterintuitive, but roughening objects can be a wise thing to do.
Your design challenge is to create the most aerodynamic shell that can travel the furthest distance against a wind source. Using the given tools, you will design and carve a shell from a block of lightweight foam to make it as aerodynamic as possible. The shell you've created will then be placed on a cart and launched against a consistent wind source. The more aerodynamic your shell, the further it will travel against the wind source.